Hey everyone, welcome back to another episode of Are You Ready for Calculus? A series of short videos where we review topics that will be useful to know as you go into Calculus 1. I said the right class this time, Calculus 1. In my first video, I said Algebra 1. But in my defense, the topic that we looked at in the last video and the topic that we're going to look at today are considered Algebra 1 topics. So you could say that they would be useful for students going into an Algebra 1 course as well. Okay, but again, we're focused on little bits and pieces of information that you should know as you go into calculus. And what we're going to talk about today, hopefully you are very familiar with. However, you might be surprised to learn how simple it will make certain things in calculus class. Okay, and what I'm talking about are properties of exponents. All right, so on this first slide, let's just start by reviewing some terminology. So if you see an expression like this, 4x to the third, we would say that the 4 is the coefficient. The x is the base. It is what has the exponent. That's the little number that you see here, or power on it. Okay, and we have all of these different properties that we look at a lot in algebra class for exponents. And I have to admit that when we look at them in algebra class, it's like one of my least favorite lessons because they just do not seem to be that exciting or useful. And really, truly, looking at all of those different properties of exponents is just preparing you to be able to use expressions with exponents with ease as you go into higher level math. Okay, so for example, in Algebra 1, let me make sure my pen is set up. Oh, it is. Okay, in Algebra 1, you might see something like, well, let's just start with 4x to the third. Multiplied with 6x squared. Okay, and what you would need to know here is that you should be using the product rule when you get to powers that says that you would be adding the powers to get the new power in the expression. Okay, the coefficients are multiplied, so 4 times 6 is 24. But x is now going to be raised to the 5th power because we add the exponents of 3 and 2. Okay, I'm not going to do an example of every single one of these. Hopefully you've seen examples of those in the past. I'm just going to jump to one that's a little bit more complicated. Okay, whenever you think about examples where you are simplifying expressions with properties of exponents, you may be thinking of something that looks like this. Does this look familiar? This super complicated mess of numbers and letters and other symbols, and we need to simplify it. We need to make it a little bit easier to work with. Okay, well, we can do that if we know our power to a power property, if we know our product rule property, and if we know our quotient rule property. Okay, let's use order of operations correctly here. Let's take the expressions that are raised to powers on the outside of the parentheses first. Okay, keep in mind this is something that is such a common mistake. The coefficient gets raised to the power. So I am taking 3 to the third power, and that is what, 27? 3 times 3 times 3, right? But now what I'm doing with my power to power parts is I am multiplying. So x to the 5th to the third becomes x to the 15th. Y to the 4th to the third becomes y to the 12th. Let's bring along the 10xy to the 7th. Nothing really to do with that right now because it does not have a power on the outside of the parentheses. In the denominator, let's raise 3x squared y to the second power, 3 squared. Remember here, you're not multiplying, you are raising the coefficient to the power. 3 squared is 9. And then we multiply the powers on the variables. X squared is x to the 4th. Y to the 1st squared, remember if you don't see a power, it is a power of 1. That just becomes y squared. Okay, now there's a number of different things you could do with this. I'm just going to go the route that I think most math teachers would take, which is to simplify the numerator by multiplying these two expressions, bring along the denominator, and then finally simplify from there by dividing. Okay, so now what I'm doing is I'm multiplying the coefficients of 27 and 10. Multiplying 27 times 10 is 270, right? But now what you're going to do with the powers on the variables is add them. This is your product property again. Okay, so 15 plus 1, remember there's a 1 right here on this x. 15 plus 1 is 16, so I have x to the 16th power. That is a weak looking x. We can do better than that, right? As best as I can do on this stupid thing. This is not a stupid thing. Oh my gosh, this has saved me so many times, but I'm still not the best at it. Okay, y to the 12th times y to the 7th, we will make that, add those y to the 19th, right? Mental math. All right, bring along the denominator, 9x to the 4th, y squared. And finally, let's divide this expression, 270x to the 16th, y to the 19th, by 9x to the 4th, y squared. Okay, what's 270 divided by 9? That would be 30, right? 27 divided by 9 is 3, so this would be 30. Here we have x to the 16 minus 4 is what we're now doing, right? Because that is using our, going back, quotient rule. Whenever you are dividing like bases, you subtract the powers. So 16 minus 4 is 12. And 19 minus 2 is 17. There you have it. That is your expression in a simplified form using 3 main properties of exponents. Okay, so that's what we typically see in algebra classes, right? Just you have a big mess involving powers, and you sort of just simplify it down to something that is much easier to look at. Okay, but in calculus class, what you're going to find is that the negative exponent property and the fractional exponent property are going to come in really handy. Okay, believe it or not, knowing something as simple as when you have the function y equals 1 over x, and you're going to do things with it like a derivative. Okay, I don't need you to know what that means yet, derivative. But when I say, here's what a derivative is, knowing that y equals 1 over x, maybe I should write it up here, is the same thing as y equals x to the negative 1, it will make your life so much easier. Okay, because this could be a complicated derivative if you leave it in a fraction form. But knowing that when you have, x to the first power in the denominator, you can bring that up to the numerator as an x to the negative first power. That will make this a much easier derivative to do. We're not going to do the derivative right now. I just need you to know that that is going to help you when you do. Okay, or something like y equals the cube root of x. Knowing that a root can be turned into a fractional power, and you could rewrite y equals the cube root of x as y equals x to the 1/3. Again, it's going to be clutch to knowing how to do a derivative easily of a function like this. Okay, so I hope that's some good news because these are pretty simple things, right? Let's look at some other ones just to finish up. Okay, so here's some pretty simple things that are going to really come in handy as you work through Calculus 1 and you encounter powers. Okay, something as simple as taking a negative 8 to the 2/3 power and knowing, okay, the third part of that power is a cube root. So I could take the cube root of negative 8, which is negative 2, right? Let me get a different color. I like mixing up my colors here. And so what I now have is negative 2 squared, and that's 4, right? So negative 8 to the 2/3 power, I can easily calculate in my brain as 4. That's going to be helpful. Sometimes students get the most scared of something like that. They're like, no mental math. It's okay. It's all right. We'll work on it. Okay. Or something like this, looking at a function like this and knowing that you could rewrite it as y equals negative 5x to the negative 2 plus, what would the next term be? See if you can get it before I write it. I messed up my plus sign. What would that be? 6, coefficient of 6 in front of your x to the negative 1 power. Let's leave this one as it is, minus 8x cubed. Okay, that might be kind of ugly to look at. Negative powers aren't too pretty, but boy, writing it like that and then doing a derivative or, much later an antiderivative, don't these words sound so much fun? It's going to be pretty easy with a function that looks like this rather than this. Okay, let's try another one with a couple of square roots. What would we do here? What color should I use? Let's go with orange. How are we going to rewrite this one so that we just see coefficient x and power? That's the goal here. A coefficient, if there is one, x, because all of these have x's in them, and a power instead of these other symbols. What do we do with that? Well, a square root is an x to the 1/2 power. Okay, get used to knowing that because you will need to know that a whole lot in Calc 1. Okay, a square root in the denominator is an x to the negative 1/2 power. So this plus 3 over root x, I'm going to rewrite it as plus 3x to the negative 1/2 power. Square root in the denominator comes up as an x to the negative 1/2 power, or as a negative 1/2 power, whatever's inside. Okay, the next one looks good to me. Let's leave it. 6x to the 5/3. Yeah, I like that. We want to keep that coefficient x power. We like that for calculus. Okay, and then finally, 7 over x cubed. How could you rewrite that one? Can you figure it out before I write it? That would be plus 7x to the negative 3rd power. Okay, again, knowing something as simple as how to rewrite this function in this form is going to be very useful for you in Calc 1. Okay, and finally, one more. Knowing that an expression like this, 1/2 times the quantity x plus 3 to the negative 1/2 power, is the same as, sorry, I don't have my pen ready, is the same as this. I could just write it equals here. 1 over 2 square root of x plus 3. Does that make sense to you? Think about that. I have this 1/2, which is the 1 over 2. I then have the quantity x plus 3, but it's raised to the negative 1/2 power. So knowing that that is the same as a square root to the square root of x plus 3, that's going to be helpful as well. Okay, I've encountered times in class where my students will end up with an answer like this, and maybe they're working on a multiple choice problem, and the correct answer looks like this. Okay, understanding that these are the same thing will be important. Okay, everybody, that's it for today's episode. I hope that this was helpful to you, and as usual, if you want more help, make sure to check back with the channel soon. Bye.